Hi, welcome to EC&M Tech Talks. This is a series of how-to videos where we cover everything really from the equipment that we install out in the field to the codes and standards that govern the installation and the maintenance of that equipment as well. I'm Randy Barnett. I'm your facilitator for this Tech Talk presentation, and it's brought to you by EC&M Magazine. That's ecmweb.com. So what you want to do, if you haven't already, as I always say, you want to go to ecmweb.com. And in the upper left-hand corner, there's a drop-down menu. Go ahead and click on that, and that very first item is premium content. So if you haven't already, go ahead and sign up for the premium content. It's free, and you'll get lots and lots of information that pertain not only to what we're talking about today, but to, well, everything else in the world of electrical construction and maintenance. So anyway, let's get going. Today, we're going to talk about something that changed for the 2023 code. So as always, I'll be working out of the most recent edition of the code book. And in 2023, there was a change to a term sentence that had been in the code book since, well, I suppose probably since before I was an electrician, and that's been a while ago. And it had to do with something called neat and workmanlike manner. We've always had a requirement to do all of our work in accordance with neat and workman, or in a neat and workmanlike manner. Probably most of us could come up with some type of definition for that and so forth, but it changed for 2023. The terminology changed. The intent didn't. We still have to do our work the same way in accordance with our codes and standards and other recommended practices that are out there and so forth. But what did the terminology change to? Well, let's go to 110.12 and take a look. 110.12 in my 2023 code book is titled Mechanical Execution of Work, as it has been forever and a day, right? It says that electrical equipment shall be installed in a professional and skillful manner. So we changed the terminology to professional and skillful then, from neat and workmanlike. And there are actually 7 public inputs in order to get this change in effect. And they really centered around that the terms neat and workmanlike were vague and specific and could really not be defined very well. Thus, it was often subjective as to what one person, I might think my work, oh, that's very neat and workmanlike. That's the best conduit run you've ever seen. Whereas somebody else might say, nah, you really ought to think about doing something about that conduit run. So anyway, we tried to find some better terminology. Also, one of those 7 public inputs said that the term workmanlike was not gender neutral, which is true. So it's changed to professional and skillful then to give us some more direction. Now, professional and skillful is not designed, or excuse me, is not defined in Article 100 of the NEC. So the NEC and the style manual, whatever, tells us that anytime we run into a term that's not defined in the code book and we want to know what the definition is, to go to the Merriam-Webster's Collegiate Dictionary, edition 11. And so I did that, and I looked in there for the terms professional and skillful. And as you can imagine, they revolve around things like compliance with codes and standards, which is certainly part of being professional. Skillful talked about things like, following known methods of, well, we would call it installation and maintenance and so forth. And so really, yeah, those terms fit professional and skillful. But how do we get more direction out of that? How do we really learn more about what professional and skillful is? Now, in this section 110.12, there's this statement about mechanical execution of work being done in a professional and skillful manner. Then there's an informational note. Then there are 3 more sections underneath that, 110.12a, then B, and then C. Section A is on unused openings. So we have to plug unused openings, don't we? This is stuff that has not changed. It's already been there. But it's talking about giving us some direction then on professional and skillful. So if I have this box up here, and maybe it's a box we used on the last project or whatever, and it's got some holes in it where we have some conduit. Maybe the conduit came in the bottom before, and now we're coming in from the side with this type MC cable. What we need to do is to go to that opening that's still on the bottom and put in a little plug, don't we? Okay. And so a knockout plug. So we put that in and snap it in place. Pretty easy way to take care of that. There are different types of these and so forth. So we need to do that. And the whole idea, if you think about that being professional and skillful, that's doing it right. Okay, do it right. I don't want rodents to get in there. I don't want, hopefully, no moisture, dust, dirt, things like that. Anything that it can impede the operation of my system. So I put in my knockout plugs wherever required. And certainly, I don't want somebody to come along and stick a finger like in the side of this enclosure, that panel board or something like that, right? Could be very dangerous. 110.12b talks about the integrity of the electrical equipment in. I don't paint on the inside. So if I'm going, I have to protect that box, right? If I've installed it, maybe in some drywall or whatever, and the code tells me how to install that box in drywall or on a surface or whatever I'm doing. And I don't want the painters to come along and spray the inside of that box. Also, there's going to be another installation standard we're going to take a look at that's going to talk about cleaning all of the old dust and dirt and drywall out of that box before we actually install the conductors in there. So anyway, integrity of our electrical equipment and connections then. Cables and conductors. Cables and conductors have to be properly supported, and this is subsection C. Right? And if they're on the surface of the ceiling or run along the horizontal run of a wall or something like that, vertically, whatever it is, they have to be properly supported in accordance with all of the other code requirements that apply, probably back in chapter 3, right? And then there are a couple more informational notes. We're going to go back to that first informational note in just a minute, but there's some informational notes down here in subsection C that we don't often pay close attention to. So let's take a look at those. So this is cables and conductors, 110.12c. Cables and conductors installed or exposed on the surface of ceilings and sidewalls shall be supported by the building structure in such a manner that the cables and conductors will not be damaged by normal building use. This is going to reference to this first informational note is going to take us to NFPA 90A, which is the standard for installations of air conditioning and ventilation equipment. And really, if you think about it, that ties, this is going to tie us in, and actually this information in NFPA 90A is going to help us support 300.22c. And 300.22c is wiring and ducts not used for air handling, fabricated ducts for environmental air, and other spaces for environmental air, what we call plenum. So for example, what this NFPA 90A is talking about. Okay, so I have two places that it's going to give me specific information for the conductor types, insulation, so forth, cable ties, and whatnot that I can use where? Under floor in my ventilation spaces, and above that suspended ceiling overhead. So what we do is we bring in environmental air, typically, don't we, through some type of ductwork into the room so that we get some nice, fresh, properly humidified, proper temperature air and so forth. And then the return goes up, and that air just goes through the suspended ceiling or ventilation opening and goes through that suspended ceiling and back to the air handler. So what can I do above that suspended ceiling? What can I do down below the floor? So that 90.A NFPA standard helps us to comply with 300.22c then. Information note number 2 under 110.12c talks about plaster, paints, cleaners, abrasive, corrosive elements, and fiber optic cable. So fiber optic cable is a little bit different from our normal electrical cable, isn't it? And so it asks us to take that into consideration, paint, plaster, cleaners, and how it's going to affect our fiber optics. Now, let's go back up to this first informational note right under the general heading for 110.12, where it says mechanical execution of work. And the statement says, electrical equipment shall be installed in a professional and skillful manner. Then the informational note. The informational note says, see ANSI NECA 1-2015, Standard for Good Workmanship in Electrical Construction. And then it says also refer to other ANSI approved installation standards for information on accepted industry practices. So for instance, that NFPA 90A standard would give us some additional information then on installing in air plenums that we just talked about. But let's talk a little bit about this ANSI NECA 1. So ANSI, American National Standards approved. Okay, so that's a good thing. It means it's a consensus standard. It is another industry best practice then. And NECA, the National Electrical Contractors Association. So they put out this document several years ago for us. They've revised it a few times, and I understand it may be under revision now. And so it talks about good workmanship when we do our electrical installation. The terms neat and workmanlike did not go away completely, by the way. If you were actually to go back to the index in the back of your NEC 2023 and look up the term neat and workmanlike, you will find that term still exists. And I think I found it in 5 locations. For instance, Article 724, Class 1 power limited circuits and Class 1 power limited remote control and signaling circuits. This may catch you off guard a little bit on Article 724 and 725. If you haven't already noticed, those have changed in the 2023 code. Then 724 is a new article and 725 has been revised then. So, and what it is, 724.24 says Class 1 circuits shall be installed in a neat and workmanlike manner. Article 725 now is on Class 2 and Class 3 power limited circuits. Says the same thing, 725.24, Class 2 and 3 equipment shall be installed in a neat and workmanlike manner. Article 760 is on our fire alarm systems. So sure enough, 760.24 talks about the installation of our fire alarm systems, and it says mechanical execution of work. Fire alarm circuits shall be installed in a neat and workmanlike manner. And then finally, we have Article 770 in Chapter 7. Article 770 is on fiber optic cable or optical fiber cable. 770.24 says optical fiber cable shall be installed in a neat and workmanlike manner. So the intent is still the same, right? However you want to word it, we do our stuff professionally. As I always say, this whole statement, what it really requires us to do is to be proud of our electrical work, whether it's installation or we're doing some installing a motor, doing some maintenance work or something like that. When we're done with it, we want to back up and, you know, be able to say, yeah, I did that over there. I'm the guy that did that, you know. And so that it's pride and workmanship. And the reason for that, people say, well, what does that have to do with the code? As long as I follow the minimum requirements, I'm okay, right? Yeah, but really, okay? So if you're inspecting some electrical equipment and you find a conduit run going into a box or something, and it's maybe that you grab that conduit in that box or something, and you notice it's a little loose where that conduit terminates on that box. That's not good. That shouldn't be, right? Somebody didn't tighten up a lock nut or whatever, or properly install a fitting. So now all of a sudden you might have a question about the rest of their work, right? Did they size the wire properly? Did they pull it in properly? Is the box clean on the inside before they install the wire? All those type of things. Not to mention, you've created a safety hazard with that loose termination, haven't you? What if that's metal conduit going into that box? That's part of our equipment grounding conductor path. And now we may be interrupting that path or creating a high resistance connection. And either way, that's certainly not good. So we do have references back in Chapter 7 then, back to that term neat and workmanlike. In Chapter 8, now remember, Chapter 8 is our communication system. It is a standalone chapter. The first 7 chapters don't apply. So if we want a requirement in Chapter 8 about neat and workmanlike, we're going to have to put it in there somewhere. So in Article 800, which is on the general requirements for communication systems, 800.24 again talks about circuits and equipment shall be installed in a neat and workmanlike manner then. Let's talk a little bit then about that ANSI NECA standard and this NECA 1 standard. NECA 1, National Electrical Contractors Association. This is a copy of the standard. I've been through it. I've marked it up, looked through it. I studied it. I've had it for a long time, right? And this is a 2015 edition, as I say. Once again, it's ANSI approved, so it's considered an industry best practice. Let's take a look at the things that are in here that can help us to meet the 110.12 requirement. Because really, it says professional and skillful manner in 110.12. Well, we know, for instance, if we're going to go install some conduit, the minimum requirements for supporting, securing that conduit are back in the associated conduit article back in chapter 3, isn't it? But what other information is there that might be nice to know? For instance, sometimes we're told to make sure things are wrench tight, especially I'm thinking, you know, like in chapter 5 on our hazardous classified locations. What does wrench tight mean? Where does that come from? So anyway, not defined in the code book. Code book doesn't tell you how to install this. It only gives us the minimum requirements for compliance in. There are actually 10 topics, I guess we could call them, to NECA 1 that are of importance to us. So let's talk about these a little bit. One of the first things is actually chapter 2. Chapter 1 is some administrative information, but it talks about receiving and storage of our electrical equipment. Now, it makes sense. If we're going to take electrical equipment, receive it, put it down over here in a laydown area or in a container somewhere or something, we want to keep it clean and dry. We want to inventory it when it first comes in. We want to inspect it, make sure it's in good shape. We got the parts that we were supposed to get. If we're short of any parts, if they're back ordered, something like that might be common, we need to note that on the inventory, what parts are back ordered. Then we need to close it back up. We don't want to unpack it entirely, just enough so that we can inventory it and inspect it, close it back up and keep it free of dust, dirt, moisture, any type of contamination. Keep in mind, I don't want to keep that stored certainly in a corrosive area where it's going to be subject to corrosion and so forth. So that's what it's talking about in 110, or excuse me, talking about in chapter 2 of the NECA 1 standard then. The next topic is general requirements, okay? And it talks about good, you know, it uses the term workmanship again. It says it must be apparent, shall be apparent in the installation of electrical materials and equipment. So when I look at it, I go, boy, that's well done. Look at those concentric bends in that conduit. Look at that saddle. Boy, that's a good job. This person knew what they were doing, and they took enough pride in their work to make sure that it was done properly. All materials have to be firmly secured in place. Yeah, there are requirements in the code about that. Everything has to be true, plumb, and level. You know, when I put it up on the wall, that box, if I put a little level on the top of it, it's going to show that it's level. And then I want to make sure that it's squared in there, properly attached. It's true and plumb, being square to that wall and so forth, and level. So I make sure of all of that. All materials and equipment and so forth, if they have to be corrosion resistant, they're corrosion resistant. That includes moisture as well, doesn't it? Is that equipment suitable for that wet or damp location? Seismic requirements is another issue as well. Some places it's not a big deal. Other places, seismic requirements are very important. Anchors and fasteners. Whatever I'm doing, you know, in support, hangers and all this, I mean, here's this little guy right here. I'm going to use this to support some conduit. And so one is at the right size. It says right on here on the side, 1/2 inch EMT. Is it corrosion resistant? It doesn't say. It is UL marked over here. So I could go back and I could trace this back and find out what type of environments I could use this in. Can I use it in a damp, wet location? What about if there's other types of corrosive fumes or something like that in the area? Even something as simple as this, I have to pay attention to. And so permanent and neat appearance. So anytime I install something like this, I have to assume it's going to be permanently installed. It's got to be neat in appearance as well, right? Adequate corrosion resistance. We've talked about that. 300.6 is a good reference in the code book for you on corrosion resistance. Now, this is kind of handy. It says generally screws are used on wood, masonry anchors on concrete or brick, Toggle bolts are similar on hollow walls. Machine screws, bolts, or welded studs on steel. Nails are normally used. So if I'm going to take something like this box and, that's a non-metallic box, and maybe I buy it, it's already got the nails top and bottom on it, I just got to hammer them in. So it tells me that nails are generally used either on temporary installations, or if I'm going to use it for a PVC box like this, I have to get those nails in and secured and so forth. And when the box sits in there, the box should be, once again, true and plumb. Now, obviously, the nails are only used in wood frame construction, it tells us. So think about, I've got something like a dry type transformer, maybe weighs several hundred pounds. And now I'm going to build a structure, and I'm going to hang that several hundred pounds from the overhead. Well, let's see. I think I better attach whatever I'm going to hang it with. I better attach it to that some structural members up there in the overhead, right? So that they can hold that amount of weight. And I've got to make sure somebody in engineering is going to make sure for me that those structural members can support that much weight of that transformer. Now, I'm probably going to build something, maybe I as the electrician, it might be my responsibility to take some strut and build some type of support for that transformer. And I'm going to use something like what to hang it with. Depends, maybe some all thread. So all of a sudden, I've got to know what that total weight is. And for that total weight, I'm going to include the transformer. I'm going to include the strut. I'm going to include the all thread. And that's going to give me the total weight of that particular installation then. And I've got to make sure that my strut, my all thread can support that much weight. So what I have to do is I have to go back to manufacturers, really. I'm not going to find this in the code book and find out, for instance, a size half inch piece of all thread. If it's grade 5 or 8 steel, I've got at least 2.5 inches of thread hanging there. Tells me it'll support about 300 pounds. Now, don't take that to the bank, right? You go back to manufacturer's instructions and look that up. If it's titanium thread, it may support 800 pounds. But that also depends on whether or not it's fine threads or rough threads. That'll change all of those numbers around for me. So anyway, there's some research there that needs to be done before we just hang something off of the structural ceiling. And that's what it's talking about in Chapter 5 of NECA 1 standard, hangers and supports. The next topic, Chapter 6, is on outlet boxes. So I can have all type of outlet boxes. So where do I put my outlet box? Well, I'll just stick it on the wall somewhere. No, probably not. There we're going to see there are some recommended heights for all of this, but it has to be rigidly attached, supported, true, plumb, all of those things we already know about. And I've got to have it clean before I put my conductors on the inside. Those things that we talked about. I like this statement. It says installation of outlet and device boxes shall be coordinated with other trades such as drywall and painting. If you do construction type work, you're thinking, yeah, it's not always that easy. Keep in mind too, though, a lot of people that are listening to this tech talk, they're not construction electricians. If I'm an industrial electrician, as I've been for many years, in some industrial plant, power plant, manufacturing plant, or elsewhere, I am not a construction electrician by trade. It may have been several years since I ran any conduit. And all of a sudden, we got a new pump skid in today, and it's my job to run some rigid and some flex over to that motor and get it all hooked up and ready to go and all of that. So it may be requirements that I'm not familiar with simply because, as I always say, use it or lose it, right? So if I haven't done it in a while, I'll start to forget, especially when it comes to bending conduit, right? So anyway, so this standard becomes really good for us, this NECA 1 standard for not just new construction, but for anybody who does installation type work, whether it's dwelling units, residential, in other words, or other than dwelling units, manufacturing, industrial, pipelines, wherever it is, wherever you're working. Junction and pull boxes is Chapter 7. And so junction and pull boxes, things we've already talked about, any knockouts have to be plugged. It has to be true and plumb when I mount it, corrosion resistant for whatever the environment is. And it's going to have a cover on it. Raceway shall be arranged to provide the longest sweep or radius into the box. Makes sense. I don't want to bend conductors any more than I have to, and I have certainly bend radius requirements back in the in Chapter 3 of the code. Covers for large junction of boxes. If my pull box, let's say, If I have a pull box that's 6 square feet or more, so that's 3 feet by 2 feet, it says I have to have hinges on it rather than trying to hold that cover up there and put it in place. And raceways is chapter 8. And some of the information that's not in the code book, is spacing of conduit support. So there are tables in chapter 8 of the NECA standard. Now, there are minimum support requirements in the code book, right? But once again, I can go to table 1A in chapter 8 of the NECA 1 standard and find out on whether it's a horizontal or vertical run, my spacing of conduit supports, my maximum support spacing distances and so forth. Care should be taken to prevent the entrance of foreign matter. So once again, things like our knockout plugs and things like that are good, but also consider the location of where you're installing the equipment. When I do an offset, so if I do an offset, right, and I don't have an offset with me, but if I were to bend an offset and come up off of this conduit and come up here, go that way a little bit, and then I go straight up into the box, right? It says that run going straight into the box has to be parallel with the rest of my conduit down here. That sometimes, if without experience, that can be a little tricky. Once you get it down, you can get pretty good at it, but nonetheless, it takes a little bit of practice. Some other things that I want to look for: I don't want to overbend my conduit, and there are requirements in chapter 3 of the NEC on my bend radius and all of that type thing on my different types of conduits. I don't want to, and the thing that I'm looking for is when I bend a conduit, I don't want to make the inner walls of that conduit significantly any smaller than what they already are, right? Because if I bend it too tight or if I get a kink in it, I just change the dimensions on the inside of that conduit wall. And all of a sudden, I don't have as much space inside of that conduit as I thought I have. I pull a conductor through there or something, I may scrape some insulation off or something like that. So items to consider then. Chapter 9 is on wire and cable. Well, lots of information in chapter 3 on the NEC, right? On our different types of conductor installations. There are tables in the back. We have table 310.16 is the one we probably most often use for ampacity of conductors, sizing our conductors and all of that. So plenty of information in the code book. But what's in addition to that? It kind of sums up a few code requirements in the beginning of this chapter 9 of the NECA 1 standard. Then it says some things that we really don't address in the NEC then is the actual installation technique. So things like proper pulling, using the proper tools to pull in the conduit, proper devices and accessories and all of that, and the proper lubricants to pull the conductors inside of the conduit. Conductor splices shall be kept to a minimum. Code book doesn't tell me that, but that makes sense. I should certainly strive to do that. Discussion point is how conduit runs must be made, and must they be the shortest distance or anything like that between 2 points? The answer is no. You're the electrician, you're installing that. You look at a print and all you see is a line going from point A to point B, don't you? You probably got to figure out how to get it from point A to point B and what boxes you need in there and what types of bins and fittings and all of that type of information. So you're the professional, you need to be able to figure that out. Professional and skillful manner. And it should look neat when I'm done, right? It should look like something somebody took pride in when they walked away from that job. When using cable ties, do not over tighten. We talk about cable ties in the NEC, but it doesn't say anything about if you over tighten them, you could damage the insulation. Yeah, I guess I knew that, but it's not something that I would normally think about, but something I should pay attention to. All conductors shall be identified in the panel board. So inside the panel board, every wire that comes in there should be identified. Whether I use some type of wire label or whatever it is, or a tag or whatever, and let me know what that conductor is supplying, maybe probably what breaker it's going to and so forth. So it's got to be properly identified. Something else we have to watch, and it talks about it in the NECA 1 standard, is when it comes to stripping that insulation off of that conductor to put it into a wiring device, don't strip off too much or too little. We don't want any more bare conductor coming out of that terminal than needed, and we don't want any insulation underneath that terminal screw, do we? So we pay attention to that. A lot of these devices have the markings on them of some type of little strip gauge, right? To show us how much wire to strip off. And then mounting heights, finally, mounting heights is chapter 11 of the NECA 1 standard. If I look in the code book, there's information on how to install this box and where it goes, and how many of them I need is on my prints or whatever, probably. And there's, certain distances, that 12-foot requirement, dwelling unit applications and so forth. And lots of information on receptacle outlets and switch outlets in the code. But one thing it doesn't tell me is how high up do I mount it and where do I mount it? So it tells me in the NECA 1 standard, it gives me some information. It tells me, for instance, switches need to be opposite the hinge side of the door. It should be as close to the frame of that door as possible. As far as mounting heights, it tells me, hey, I go ahead and I take a wiring device and I'm going to put inside of this box, and it gives me the distances from the center of the wiring device down to the finished grade of the floor. Okay? And because according to the code, they don't care whether I mount it at 5 feet or 2 feet or 1 foot, right? Let's take a look at some of those dimensions. And so once again, these are from the finished floor to the center line of the wiring device. So for wall switches, it says 48 inches. For receptacles, 18 inches. Probably, and if you install these every day, you know this. If you're in an industrial plant and you only install them occasionally, you may not remember this. Data outlets, 18 inches. Wall lighting outlets, 84 inches. Thermostats, 48 inches. So if you think about it, we've got receptacles at 18 inches, and we've got a lot of our switches, thermostats, and so forth at 48 inches. Push buttons, 48 inches. Clock outlets, 96 inches. Now, fire alarm pull stations, 48 inches. So just like the switches, I want to be able, readily accessible, I can run up and grab it and pull that handle down as I need to, right? So for fire alarms, gongs, bells, horns, and lights and so forth, I'm going to mount them on my wall. It's got to be a minimum height, it says, of 80 inches, but it can't be any closer than 6 inches to the ceiling then. So that's some pretty good information. Panel boards. So you think about it, panel boards, disconnect switches, all the same. From the center of the grip of the operating handle, when it's in the up position, say on a disconnect, down to the finished grade of the floor, no more than 6 feet 7 inches. And so the same is true on the panel board. From that top breaker down to the floor, no more than 6 feet 7 inches. Those distances, it also notes, which I think is important, they also meet the requirements of the Americans with Disabilities Act. So anyway, that's the NECA 1 standard in a nutshell for you. Lots of information on all kinds of stuff and boxes and fittings. Oh, the wrench tight. You actually have to go to the NECA standard for metal conduit installation, and it'll tell you that for a given size, trade size of conduit. For instance, I think it's on a 1-inch conduit. You take a 14-inch wrench, you go ahead, you hand tighten your fitting first, and then you take that 14-inch wrench and you continue to turn that fitting, taking up or no more than 3 threads on that pipe that you're attaching to, then disappear as you wrench tight that fitting on there. So anyway, that's it. Remember that this is brought to you by EC&M Magazine, ECMWeb.com, which is in the portfolio of the Endeavor Business Publications, all righty? So the main thing is that you go out of here, you work safe, and install this stuff properly, because why? It's here to protect people and property from the hazards arising from the use of electricity. All this is based on practical safeguarding then. So until the next Tech Talk, I'm Randy Barnett. Work safe.